Alrighty, we're gonna start off with some circle geometry. Okay, let's see if you've done this in grade 9. I doubt it, but we can still do this. Here is a quick question. So there's a stone being dropped in a pond, and it's creating a ripple. And the radius of the ripple is it's 4 centimeters per second. It's going up by, and it says determine an equation that models the ripple 10 seconds after the stone is dropped. All right, have you done equation of a circle? It has this form, okay? Equation of a circle. It has x squared plus y squared equals r squared. This
No.
is the main form of a circle. Basically, you've seen y equals mx plus b, yeah?
Mm-hmm.
If they give you this, you're able to draw the line, right? And we've done quadratic as well, y equals x squared or something. If they give you this, we can draw a parabola, but similarly, right, for a circle, they give you something in this form, you're going to be able to draw the circle itself. Here, let me give you some examples. So again, this is the general form where r is the radius, okay? R is the radius. Let's say they ask you to graph this. X squared plus y squared is equals to 9, right? Like this. So in
Mm-hmm.
this equation, what's the radius? Compare this with this, right? R squared is 9. Then what does that mean about the radius? It's going
It's
to,
three.
it's 3, right? So what are we looking at? We're looking at a circle that has a radius of 3. So it goes 3 units on the x-axis, positive, -3, top 3, and then bottom 3 like that. And then you just kind of just make a circle out of it. There you go. That's so if you plot this on Desmos or a graphing calculator, you're gonna get a graph like this. Well, their circle is gonna be better, but it's the same idea. It's gonna pass through these 4 points and there's gonna be a circle. This is the general form of it, okay? But things get
Mm-hmm.
a little bit trickier because this one we're assuming, what this one assumes is that the center of the circle, okay, center of the circle is going to be at the origin. It's going to be at the point 0, 0 right here. So this form always assumes center of the circle is going to go through the origin, or it's going to be the origin. Here's a different form. You can get something like this: x minus h squared plus y minus k squared is equals to r squared. This is a more this is a better equation because this one, the center can be anywhere, okay? Here, look at this. We're gonna do the same example as last time where the radius is still 3, right? But now I'm gonna change some things. X minus, let's do 2 squared plus y plus 1 squared. So radius is 3. What's our h? H is 2, okay? Compare this with this.
Mm-hmm.
Minus h with minus 2, h is gonna be positive 2. What's k?
1.
K is gonna be -1, okay?
Mm-hmm.
Because we're comparing negative k with positive 1, therefore k is -1. Now, what does this give us? This gives us the center of the circle. H and k is the center of the circle. Now, drawing this is a little bit tricky. So our center of the circle is at 2, -1. So instead of being at the origin, it's at 1, 2 is here, -1 is here. This is going to be the center of the circle, okay? Now, how do you graph this by hand? Again, we know the radius is 3, yeah? So
Mm-hmm.
this is -1. I'm gonna go 3 units up. So -1, 0, 1, 2. I'm gonna end up there. Okay, up 3, and then again to the left by 3. I'm at 2. I'm gonna end up at -1 on the x. I'm on -1 on the y. I'm gonna go down by 3 units. I'm gonna end up at -4. Okay, and then finally I'm at 2 units. I'm gonna go to the right by 3. I'm gonna end up at 5. There you go. Those are the 4 points. It's not gonna be super precise here, and then you just kind of join them. So that if you put this on a graphing calculator, this is what you end up with. The only difference is now the center of the circle is gonna change, okay?
Mm-hmm.
So that's what it comes down to. This one, again, if you look at this, I can skip this. Let's try doing this. It's a very simple question, right? Look at this. X squared plus y squared equals 25. Doesn't even take 10 seconds. It's a circle with at the origin, the center of the circle, and it's 5 units each way. So up, down, left, right, all by 5, and then you just connect them. And all these are gonna be 5 units, right? +5, -5, -5, +5. And that is it, okay?
Mm-hmm.
That is it for a circle. Let's see, it's gonna get a little bit tricky though. Oh, they found some other things actually. Let's find some other things as well. What have they found? They found the x-intercepts, that's easy. They found the y-intercepts, that's easy as well. And what else have they found? Looks like they found the midpoint. You know what a midpoint is?
No.
Midpoint is basically, let's say you start here, you end up there, this is the midpoint.
Mm-hmm.
Exactly in the middle, okay? Exactly
Okay.
in the middle. I'm gonna show you how they got this bit, -3 and -4. Actually, you don't need to calculate it because once you draw it, usually you do this with a compass, yeah? If you put
Mm-hmm.
it at -5 radius like this, if you put your compass, the pointy end here and the other end at the center, right? Because this is gonna be a constant, so it's gonna automatically, it is gonna go through these points. Like you see this point here? It's
Mm-hmm.
automatically gonna touch that point as long as you do this right with a compass. But what's the significance of that -3 and 4? Look at this. We're gonna come up with a triangle, okay? Let's say
Mm-hmm.
something like this. We know this is 5 units, yeah? See
Uh-huh.
this? 5 units. This is going to be a right angle triangle, right? Do you
Mm-hmm.
remember your Pythagorean triples? It's gonna be in this form, x squared. No, it's not that form, right? It's gonna be this. A squared plus b squared is equals to c squared. This is the Pythagoras theorem, right?
Mm-hmm.
You remember any examples of a, b, and c? The first one, okay, the most famous one, or the one you're gonna see multiple times, is this 3, 4, 5, which means 3 squared plus 4 squared is equals to 5 squared, yeah?
Mm-hmm.
That's a Pythagorean triple. So whenever you get 5 as the hypotenuse, okay, you can safely assume, as long, well, you can't safely assume, but more often than not, if it's a symmetrical diagram like we have here, okay, then when 5 is your hypotenuse, then the other two sides are 3 and 4. Okay, here, let me give you another example of a Pythagorean triple. Another famous one, 8, 6, 8, and 10. Same idea, 36 plus 64 is 100. This is gonna be another Pythagorean triple. So whenever you run into something like this, that has a 5 or a 10 as a hypotenuse, then you can assume, as long as it's symmetrical, that the other two sides are 6 and 8, okay? But this one,
Okay.
how do they get the 3 and 4? When you draw this with a compass, it has to pass through this point, okay? Because this
Mm-hmm.
uses the idea of a Pythagoras theorem. Let's look at another question here. A circle has a center at 0, 0, okay, 0, 0, and it passes through 8, -6. So 8, -6 is down there. That is going to be 8, comma, -6. So we know our circle is going to pass through this, yeah?
Mm-hmm.
What is this called? See this line? Our circle is going to look like this. We don't know what it looks like yet, but we're going to get a line from the center to that point. What do you think that line is called?
The radius.
The radius, exactly. So the radius, right? What do you think the radius is? Again, we have 8 and 6. You can it's gonna be 10. Okay, I'm gonna show you exactly how it's gonna be 10. You turn this into a rectangle, not a rectangle, sorry, you turn this into a triangle.
Mm-hmm.
So this unit here, from here to here, on the X you have 6 units, and on the Y you have, sorry, 8 units, and on the Y you have 6 units. 8, 6, we talked about this before, use Pythagoras theorem, it's gonna be 10, right?
Mm-hmm.
So your radius is 10, so that means you're gonna be going northwest by 10 units as well. You're gonna end up somewhere here.
Mm-hmm.
You're gonna go northeast by 10 units. You're gonna end up here, and you're gonna go southwest by 10 units. You're gonna end up here. Now use the power of symmetry, okay? The symmetry is very powerful here when it comes to circles. If this is 8, -6, what do you think this point is? It's a reflection on the y-axis, okay? You can think about it that way. It's a reflection on the y-axis. We take this point, right? We threw it over here. Is the y value gonna change?
No,
No, the y value is still -6. What about the x value?
it becomes negative.
It becomes negative. So there you go, -h6. Now again, throw this point up there. On over there, y becomes positive, and throw that point over here. Both of them become positive like that. There you go. Okay.
Mm-hmm.
And you can just use a compass with the pointy end here and the other end here, and then kind of just join the dots that you have right now, and that'll give you the circle. Okay.
Mm-hmm.
Like that. And there you go. It's not a perfect circle, but that's how it does work. Part B, it says, wait, first question, it says determine the equation of the circle. We know it goes through 0, 0. So we're looking at this equation, x squared plus y squared is equals to r squared. So x squared and y squared, they don't change. What's r squared? Remember, r is 10, yeah? R means the radius. If r is 10, what's r squared?
100.
100. So equals to 100. That's going to be the final answer for part A. B, determine the other endpoint of the diameter through 8, -6. So 8, -6 is here, okay?
Mm-hmm.
So it wants this point up here, which we already have, right? Using the power of symmetry, that's just going to be -8, 6. And you are done with this question, okay? Pretty easy.
Mm-hmm.
How hard can this get though? Let me just see how hard can this get. Let's do one where we need to read a graph instead of reading an equation. Right. It says state the x-intercepts. Now be careful with the scale here. It's going up by 2 units each time. What do you think the radius is here? The radius is the distance from here to here.
It's
It's a number between 4 and 8.
6.
It's not 6. Try again. So this is 2, right?
It's 7.
It's 7. Yeah, this is 6. And that number is between 6 and 8. It must be 7. So for part A, it says state the x-intercepts, right? X-intercepts just means we have +7 and 0 on the right, that point, and then you have -7 and 0. Those are the x-intercepts. Now we have the y-intercepts as well, part B. The y-intercept will be 0, 7 and 0, -7. Those are the y-intercepts. C, state the radius. Super simple question. Radius is 7 units. D, write the equation. What is it going to be? X squared plus y squared equals what? It's going to be a number here.
7 squared.
Yeah, 7 squared. 49, and we are done with this question. Easy. Most of these are pretty easy. Like, look at this. The radius here is 6. The radius here is 7. What's the square root of 169?
Is it 13?
Yeah, it is. So the radius here is 13. The radius here is 0.2. Okay?
Mm-hmm.
Not 0.02. It's going to be 0.2. Let's look at the next question here. Use the information to write an equation with a center at 0, 0. All right. Super simple. Part A, radius of 11 units. X squared plus y squared equals what? If the radius is 11.
121.
121. B, x-intercepts as -9 and +9. So what is the radius? It is going to be 9. 9 squared is 81. Part C, x squared plus y squared equals what?
16.
Yeah. Part D, diameter of 12 units.
36.
Yeah, good. And you are done. Easy peasy. This one's gonna throw you off. Says, which of the following points are on the circle with an equation of this? You could sketch it, but it's not gonna help you here. The radius is gonna be what, 8 point something. How do you think we approach this problem? You have all the tools you need. You just need to think about it. It's pretty simple, okay? All you have to do is plug this as X, plug this as Y, and see if that's 65. So for A, it's going to be 16 plus 49, right?
Mhm.
Which is 65. So therefore, this point is on the circle. B, you have 25 plus 36. That's not 65, so no. Third one, you have, again, you plug this as X, so it becomes 64. You plug -1 as Y, it becomes +1. That is 65, so that is on the circle. Last one, 9 plus 36, it's 45. That is not on the circle. And that's all there is. Just plug and see if the equation holds true. Okay, write an equation for a circle that models each situation. Super simple question. The possible locations of the epicenter of an earthquake, which is recorded to be a distance of 144 kilometers from a seismograph station in Toronto. So this is what's happened here. Let's say this is the station. Okay, you know what that is? Like it has
Mhm.
like a pen here and it gives you like these readings. That's a seismograph.
Uh-huh.
So how does this work? Epicenter is where an earthquake starts. Okay, so let's say this
Mhm.
is your epicenter, and let's say this is the station, right? This is the station. An epicenter goes in all ways. Okay, you see this? That station is simply what? It's on the part of the circle. Okay,
Mhm.
like this. So that means this distance here is going to be 144. So with that information, what is our radius?
12.
No, it's 144. So that'll be 144 squared. I don't know what that is, but that's what it would be. The
Mhm.
path of a satellite in a circular orbit at a distance of 19,000 kilometers. Again, same idea. This is Earth. This is center of the Earth. That satellite is somewhere up here. And this distance, okay, that distance is 19,000 kilometers. So is that our radius or is that our diameter or what's going on here? What is this equals to? That's our radius, okay?
Mhm.
That's our radius. So you just do r squared. We don't know what that is. It's going to be a big number. We don't care about it. You can leave it in this form as well. Part C, the rim of a bicycle wheel with a diameter of 69 centimeters. So what is this going to be? X squared plus y squared is equals to what squared?
Half of 69.
What is half of 69?
34.5.
Yeah, squared. The cross section of a stormwater tunnel that has a diameter of 2.4 meters. What's a cross section? So let's say this is the tunnel, yeah?
Mhm.
Let's say water comes through here and then this goes through like in the river or through a water processing facility. Cross section is you take this river, you take a knife or anything and you cut it right here, okay? You literally cut it and then you turn it towards you and this is what you're gonna see, right?
Mhm.
This is the drain and this is what you're gonna see. So this is called the cross section. So this cross section has a diameter of 2.4 meters, yeah? From
Mhm.
here to here, 2.4 meters. That means you cut that in half because this equation uses the radius. X squared plus y squared is equals to 1.2 squared. And you are done with this question. These ones are pretty easy. This one, I don't know. This one looks tricky. Not looking forward to this, but let's see. So the diameter is 24 meters. He has included a circular flower bed, which is 6 meters in diameters in the center of the garden, as well as paths that are 1.5 meter wide. Don needs to make a plan, yada yada. Determine the equation of all the circles he would need to draw. Okay. So understand what's happening. We have the main garden, right? That has a
Mhm.
diameter of 24 meters. So what's the equation? What's the main equation here? What's the equation of the biggest circle? X squared plus y squared. Diameter is 24,
So 12 squared.
all squared. Okay, that's it for the biggest circle. Now let's look for the smallest circle, which is here in the center of the garden. That thing has a 6 meter diameter. So from here to here, it's 6 meters. So what's the equation of that?
It's 3 squared.
Yeah, it's 3 squared. What else do we know? Well, we know from here to here it's 6. It says the paths that are 1.5 meter wide. So I don't know what that is. Is that this distance? It must be this distance. The width of a path. So what's the equation of this circle here? Right? That circle has a diameter of what? 6 in the center, 1.5 here, 1.5 there. That means 9, right? 9. So that means it's going to be x squared plus y squared equals 4.5 squared for this guy,
Mhm.
okay? What about this guy? What's the diameter of this thing? Do we have that information? Do we know how this is? I mean, if this is 1.5, right?
Mhm.
This is 1.5. That means this circle in here, we can find that for sure because that's just going to be 24 minus 3. That's going to be 21, okay? For this circle,
Mhm.
it's going to be x squared plus y squared is equals to 10.5 squared. We're missing this one. Can we find it? I don't know how wide these guys are. I don't think so because this is 1.5, this is 1.5. 1 circle, 2 circle, 3 circle, 4 circles. I think we're good because we don't know how wide this thing is.
Mhm.
Okay, we don't know this. We don't know how wide that is. So I think that's all 4 equations that we can use. So this will be like a 4+ question. You know what 4+ is? How are you graded? Are you graded from A to D?
Mhm.
Like a 4+ means an A+ basically.
Oh, okay.
Points A5 and 9B are on the circle. Determine the possible values of A and B. Any ideas on how to approach this? Now remember, you just plug it in, right? If it's on the circle, if you plug in the points, it should work out, right? We're not checking here. We know for a fact they're on a circle. So I'm just going to plug a5 in there. So that means x squared becomes a squared. 5 squared becomes 25. This becomes 125. So that means a squared is going to be 100. If a squared is 100, what's a?
10.
Remember, you're going to miss half a mark because it's going to be plus minus 10, okay? There's going to be one point here, and then there's going to be another point here. Anyways, the square root of any number is going to be plus minus. So that, there you go. That's the possible value of a. Similarly, the possible value of b is going to be 9 squared, 81 squared. So sorry, 9 squared, 81, plus b squared is 125. So b squared is going to be 19 plus 25, which is not a nice number. It's going to be 44. So that means b is going to be the square root of 44 plus minus the square root of 44, whatever that is. It's going to be more than 6, less than 7. Okay? So see, this is pretty simple. You just plug it in. If they give you a point, you just plug it in, and it usually works out. For this one, it says, if the equation of the small circle, that means this circle is that, what are the dimensions of the large square? What's the distance from here to here? Remember, the equation is x squared plus y squared equals 16.
So it's 16.
It's 4. Okay, the radius is going to be 4. From here to here, it's 4 units. Okay, from here to here, the radius is 4. Now what can we do using this? We know the dimensions of the small square. This is gonna be 8, right? Yeah, it's 8 by 8 for the small square. What's a property of a square? What's the main property? A square has identical length and width, yeah? So we know if the smallest one is 8 by 8, so this is 8 by 8. What's going to be the larger one? Remember, it's a square. The way I see it, you only have 2 choices. It can either be 9 by 9, right? Or it can be 10 by 10. There's only 2 options here. Which one is it more likely to be? Wherever there's a square, not a square, sorry, wherever there's a circle, there is going to be a triangle in there, okay? Because a circle, if you cut it, you're gonna see a hypotenuse. There's gonna be a triangle in there. Well, and it's a right angle triangle. What's special about right angle triangle is that Pythagoras theorem holds, okay? So do we have a Pythagoras theorem for 9? C squared is 9, or do we have one for 10? This comes from the Pythagorean triple. Remember, we've seen an 8, yeah? We've seen an 8.
There's one for 10.
Yeah, there's one with 6, 8, and 10. Therefore, out of these two, it must be this one. Okay? T here is for thinking. See this T here? So you need to kind of think outside the box sometimes too. There's only two choices. It cannot be 11, 12. Those are not even nice numbers. It's between 9 and 10. 9 is A, it's too small. And B, we don't have any C for 9. It must be 10 by 10. And that's the end of this question. Describe the circle with each equation. A, 9x squared plus 9y squared is equals to 16. What's the radius? It's a trick question. 10 points if you can tell me what the radius is for part A. Is it 4? It's not 4. Because it's not in the right form. Okay, what you need to do is you need to get rid of the 9s. So this is what it ends up looking like. And then you would divide both sides by 9. Now we're in the right form. What's our radius? If r squared is 16 over 9, what's r? Just the square root, right? R is going to be the square root of 16 over 9.
4 over 3.
4 over 3, there we go. So the radius of this is 1.33 or 4 over 3. What about B? What's the radius of B? It is, that one's not complicated because it is in the right form. It's not in the main form, but this just means the center of the circle is in a different position. So here, what's h comma k? What's h? You want to compare this with this to get what h is.
It's 2.
It's 2. What about, sorry, that should have said, this is k. Yeah, this is k. So h is 2. What about k?
-4.
Yeah, -4. What's our radius? No? R squared is 9, right?
Mm-hmm.
Then R is 3, okay? Over
Okay.
here, we had to pull out a 9 because this is not in the right form. It needs to be x squared plus y squared equals r squared, right? You can't have any number multiplying in front of x and r squared. That's why we had to pull out a 9. But here, this is okay because there's no number outside of it. So
Okay.
radius is 3, right? What does this mean? Look at this. 2, 4 is the center, 2, -4. So 2, -4, let's say it's there. How do you draw it? You put your compass, the center of it here, and the pointy end at any 3 units away. So 2, that means at 5, we're gonna have one thing, right? You do this,
Mm-hmm.
and it'll automatically make the circle for you like that. But if you want to actually find some other points, the question could be, what are some other points here? Look at this. This point here is gonna be 5, -4, right? 3 units away from the center. This point here will be, this is 2, 3 units to the left will be -1, -4. Okay? And now you got to be careful because the symmetry here is weird. It's not symmetrical about the origin. Now the next point, again, we're here. It's going to be 3 units up. It's going to be here. At, what's that? That's going to be 1, right? Or sorry, not 1. That'll still be 2 on the thing. It actually won't be there. 3 units up means -4. It'll be at -1. So that's the third point, 2, -1. And then from here, you want to go 3 units down. It's going to be 2, -7. Okay, those are going to be your points.
Mm-hmm.
And that's how you can do this. Now here symmetry fails because 5, -4, you would assume 5, +4 up here to be a point, but it's not even close to being the point. It's because this circle, right, this specific one does not go through the center, that's why.
Okay.
If it went through the sort of center, things are gonna be a little bit easier. So there's a tunnel that looks like a semicircle, which means half a circle. It has a height, this thing, of 5.25 meters. If the load is 8-meter wide and 3.5 meters high, will it fit through the tunnel? What do you think? How do you even approach this here? I'll give you a hint. Is there an issue with the height? This is this much high, right? 5.25.
No.
So height, we're good, right? Height, we're good.
Mm-hmm.
We only care about the wideness of it. What is the distance from here to here called?
The radius.
The radius, right? So radius is 5.25 this way. What about from here to here? That is
That's also
also the radius. So this is 5.25. From here to here, this is also 5.25. So what's the width of the tunnel?
10.5.
Yeah, 10.5. So we're good. This is gonna fit because 10.5 is good enough for 8.8 meters wide, and then 3.5 is good enough for 5.25. And we're done. Okay.
Okay.
So yes, it does. It's gonna go through the thing. Okay, let's try doing this. Show that ABC has 3 unequal sides. Any ideas whatsoever how to do this? They've given us a triangle. We know what the coordinates are. We need to show that this is not an equilateral triangle. We need to calculate the distance, okay, between the points.
Mm-hmm.
So this point here is -5, okay, -5 on the x, 1 on the y. This point here is 3 on the x, -1 on the y. How do you find the distance between 2 points? Turn it into a triangle,
Mm-hmm.
like this. Okay, it's gonna become a right angle triangle. What's the height from here to here? From 1 to -1, what's the height? 2, okay? From
Mm-hmm.
-1 on the y to, sorry, +1 on the y to -1 on the y, the height is 2. What about the distance? From -5 on the x to 3 on the x, what's the distance there?
8.
8, right? So there you go, 8. So now use Pythagoras theorem. That distance from B to C, okay, B to C, the distance is going to be, again, this is Pythagoras theorem. It's going to be 2 squared plus 8 squared. It's going to be the square root of 68, okay? B to C is square root of 68. Now we're going to do the same thing over here. What's this coordinate? It's something and 6. What's the x value up here?
It's 2.
It is -2.
Mm-hmm.
So again, same thing. We're going to find the distance from here to here. We're going to turn this into a triangle. And look at this. The distance we're interested in, AB, that's always going to be the hypotenuse of this right angle triangle. The
Mhm.
y distance here, we're going from 6 to 1, it's 5. The x distance, we're going from -2 to -5, it's going to be 3. And look at this, AB is going to be 5 squared plus 3 squared. 25 plus 9, 34, not even close to 68, right? And finally, we can also find the distance from here to here. We're going to trim this into a triangle going this way. What's the length of this triangle from here to here? -5, right? And what from here to here? 6, 6 to -1, 7. Okay, 6 to -1, 7 units. And then again, you find the distance. AC is going to be the square root of 5 squared plus 7 squared, 49 plus 25. What's 49 plus 25?
74.
Yeah. Turns out none of them are equal, okay? So we just turn this into a triangle. Easy as that. If you would like another approach to do this, you can use something called, again, it's the same idea, okay, but you don't have to draw it. This is called the distance formula. Distance basically gives you the side length of any shape. Distance formula. It looks like this. The distance between any 2 points, any 2 coordinates, is going to be x2 minus x1 squared plus y2 minus y1 squared, like that. I think between them, the distance was 68. Let me show you using this formula. I'm going to say this one is x1, y1. It doesn't matter which one is which. This one is x2, y2. Now look at this. x2 is 3. 3 minus -5 squared is the first one. And the next one is -1 minus 1 squared, okay? This becomes 3 plus 5, 8. 8 squared, 64. This becomes -2 squared. -2 squared is +4. There you go, you get 68 using this way as well. So this is the distance formula approach. Both of them are valid, whichever you find easy. I personally find the distance formula easy because you don't have to draw out. Okay? But it's the same exact same principle. We're using the Pythagoras theorem here as well. C squared is equals to, this becomes your A, the distance from x to x, this becomes your B. I'm trying to find a interesting question. All of them are okay. Like this one, we skipped it in the very beginning. So a raindrop falls into a puddle and the radius grows by 5 centimeters per second. Okay, so this is your pond right now. Okay, again, this one can be any shape. This is your pond right now, initially. The drop falls. Okay, what it does is it creates like a circle with a radius, like that. And every second, the radius initially it's 5. In the first second, it's 5. In the second second, it's going to be 10. Okay, in the third second, it's going to be 15. What is the radius going to be 6 seconds after?
It'll be 30.
It'll be 30. So the radius is going to be 30. So this is going to be the ripple. 30 seconds. Not 30 seconds, but it's going to be 30 units. Whatever this is, centimeters. That's your radius. It's asking you for the equation. We're going to assume this is the origin. It says origin right here. So again, it's going to be in this form. X squared plus y squared is equals to r squared. What's the number on the right side of the equation here?
30.
Just 30? Thirty squared. Okay, 30 squared because it's r squared. Make sense? This is gonna be tricky. This is gonna be a tricky thing that you're gonna be doing in grade 10. What do you think this shape is? What does it look like? Is it a square?
No.
No, it's not, right? What are the possibilities? I'm gonna cheat down here because they will give you a bunch of shapes. All right. So these are your possibilities.
It could be a rhombus or a parallelogram.
Right. It could be a rhombus or a parallel. That's actually perfect. But how do we know which one is which? What's the difference between a rhombus and a parallelogram? In a rhombus,
With parallelogram, like the sides are all the same.
yeah, the sides are going to be exactly the same in a rhombus. Step one, we can ignore the triangles because this is a quadrilateral. So triangles are out. In terms of the quadrilaterals, right, we need to first show that this is not a square and this is not a rectangle. How do we show that? We just need to show that one of the sides, right there, that is not 90 degrees. Now, what were the points here? I'm going to use the one they have the points. Nope. The points are up here. Alrighty, so P is -5, -5. Q is -30, 10. S is 20, 10. Now this is gonna be a long question. This is -5 and 25. Step one, we wanna kill off square and rectangle. In order to do that, you just have to show that one of the angles is not 90 degrees, okay? 90 degree means perpendicular, yeah?
Uh-huh.
Look at this. What I'm going to do is I'm going to find the slope from P to S, which is going to be, again, it's rise over run. So it's going to be 15 over 25. That's the slope. Yeah? From -5 to 10, rise is 15. From -5 to 20, it's 25. What's this? This is 3 over 5, which is 0.6. Next, I'm going to find the slope from Q to P. Q to P. What's the slope? It's 25. Not, is it 25? No, it's not 25. It's 15 on the Y, okay? 15 on the Y. What about on the X? 25 units, okay? And because it's going down, it's falling, it's gonna have a negative sign. So the slope here is -0.6. You remember the thing about negative reciprocals? Two slopes are perpendicular, okay? Two slopes are perpendicular if their slopes, if you multiply them and you get -1, or in other words, if one of them is a negative reciprocal of the other guy. The negative reciprocal of 3 over 5 is -5 over 3. You flip it upside down, put a negative sign, okay? -5 over 3 is not the same thing as -0.6. So this cancels out both well, it can't be any of these. So it cancels out square as well as a rectangle, okay? Now it's between a rhombus and a parallelogram. What you do is you find all the side lengths, okay? You find all the side lengths. So this will be 15 squared plus 25 squared. This will be, what will this be? From here to here. That's 25 squared plus 15 squared. Oh, these two are the same. What about from here to here? -5 on the X to 20. So it's going to be 25 squared plus 25 to 10. It's 15 squared. I'm just finding the distance. This one from -30 to -5, 25 squared plus 25 to 10 it'll be 15 squared. Notice all the side lengths are exactly the same. I'm just using the distance formula there.
So
Okay.
it's a rhombus.
It's a rhombus, yeah. You have to do one more thing. Actually, you have to show that the slope up here is also 0.6. And you have to show that the slope down here is also negative 0.6. So that's the lost part. Okay, rhombus, all four sides are equal. And the opposite angles are equal, like up here and up here. You can show this by showing that this slope and this slope are different, and then this slope and this slope are different. Okay?
Uh-huh.
And all right, that is it for today.
Okay, thank you.
See ya.